Hello. I have over the past 60 hours gotten 4 different questions by 4 different people on the topic of split damage, or just damage calculation related to that. It's an experience that once again demonstrated to me that hardly anyone actually has a thorough understanding of how damage is calculated in this game. To help those who want to understand, I made this video. We will cover first how damage is calculated, and then use that to answer some questions about split damage. Most of this information will be mathematical in nature, however I will not dwell on anything particularly abstract or complicated and try to convey a more solidified method of thinking about damage. We will first discuss damage of only one damage type. An attack that uses split damage, say physical and fire, is the same as the sum of damages each of those would do individually. As an example, a weapon with 300 physical AR and 300 fire AR would deal the same with one light attack as together do one weapon with 300 physical and one with 300 fire AR. This concerns the relation between mixed damage types, but doesn't tell us anything about what damage a weapon with 300 AR will actually do. As a side note, I will here, for the sake of linguistic simplicity, use AR as whatever is the final output of a weapon's attack rating, buffs, motion value, and everything of that sort. Let us now take a look at what properties the damage function has, and what we can learn about the formula that describes it from that. To already spoil its form is the product of the attacker's AR and a different function only dependent on the ratio between AR and defense. Damage is clearly a function taking two positive values, the attacker's attack value and the defender's defense value, and giving back one positive value, the resulting damage. To get any more detail on the topic, we need to actually go do some tests. If we hit an opponent with AR significantly higher or lower than the defense, then defense doesn't seem to factor into the resulting damage anymore. Once AR is 8 times greater than defense, the resulting damage will be 90% of AR. So damage will be just AR reduced by 10%. On the other hand, if AR is only an eighth of defense, so defense is 8 times greater than AR, then damage will be 10% of AR. Therefore, depending on the ratio between attack and defense, the damage function can reduce itself to being proportional to AR. A simple fact one can observe would be that when we keep the ratio between the attacker's AR and the defender's defense constant, the damage function again stays proportional to AR. As a test of this, we may attack an opponent who has 500 defense with an attack that sports 1000 AR. And get a resulting 667 damage. Let us then up the numbers. With Cheat Engine we can get 5000 defense and 10,000 AR. These still have the same ratio, but 10 times my AR, and the resulting damage is also 10 times higher, 6667. The ratio of damage over AR is therefore merely a function between the ratio of AR over defense. I denote here that this function will be called h. We already learned what values this function takes at its limits. For relatively small values, it becomes 0.1. And for relatively large ones, it becomes 0.9. The h function takes the value of 0.1 at or below this eighth 0.125 when the attack over defense is an eighth. So the damage will be a tenth of AR. When AR and defense are equal, so the ratio is 1, then the function will be 0.4 and damage will be 0.4 times AR. These are the first 2 points we will interpolate. We want a graph that goes right through both of these. Let us put down the most basic quadratic function, x squared. This does not go through either of those points. FromSoft, like us, will now take the extremum, this lowest point on the parabola, and move it up and right to this first point. If we graduated from school, the method of doing this should be familiar. After doing this, it now intersects the first but not the second point, so we need to rescale it. That's also a simple algebraic problem that I will skip over. We thereby get a function running smoothly in between these 2 points. With this method of putting the extremum in one of the 2 points, we get exactly the 2 ways of constructing such a piecewise polynomial. Either we take a parabola that's open upward and takes its minimum at the first value, or one that's open downward and takes its maximum at the second value. Indeed, the first of the 3 piecewise polynomials in the interpolating function are of the first type, the latter 2 of the second. And like that, we've constructed the proportionality function and with that the damage function. We can observe that the h function is monotonous and therefore the damage function is convex. We will come back to that later. So, that was the theoretical part. Of course, although we can construct a function which fulfills the criteria we laid out before, it doesn't mean it's correct. In fact, as damage from the same attack tends to deviate by 1 damage point, it's pretty difficult to say with absolute certainty that this is a perfect solution. But we do have good evidence that it is at least part of the game's internal logic. Alternative interpolations do exist. Completely different 2-dimensional functions have been used to estimate these values in the past. If we accept the points of interpolation we used earlier, then the function we got certainly wasn't the most common one. Lagrangian interpolation would be a much more frequently used smooth option, and among splines, just linear or natural cubic splines would be the default choice. The real reason to trust this version is how established it is. One test done by the dear Chris Magister, linked here, gathered the damage dealt by 1,739 AR and defense value combinations, and not one of those values differed by more than 1.5 points of damage. With simplicity and accuracy, this completely outperforms any proposed alternative. Regarding the choice of interpolating points, on a visual level, we can observe the points of discontinuity in the differential of h, something which our formula for h predicts we should get at 1 and 2.5. With that established, we can start to consider split damage. We will assume a weapon with 600 split AR, equally split to 300 physical and 300 elemental. Additionally, we take one weapon with 600 unsplit AR, let's say purely physical. A strangely common misconception seems to be that split damage is bad because of the difference in defenses. I want to argue against that idea. We will use an equal amount, 300 defense against both physical and elemental attacks. As mentioned earlier, the split attack just reduces itself to 2 attacks, one with 300 physical AR against 300 physical defense, and one with 300 elemental AR against 300 elemental defense. These 2 are equal, so the split attack just deals twice the damage of one attack with 300 AR against 300 defense. If we now take the ratio between the damages unsplit and the split AR, then use the formula we've been discussing all this time, AR times h of the ratio. The term reduces itself to h over 2 over h of 1. That's very simple. Let's be a bit more general. Consider 300 AR over 300 defense is just one instance of the ratio. We call it R of attack over defense in the case of split damage. 300 over 300 and then 2R or 600 over 300 is what we get with unsplit damage. Then the ratio of the damages of unsplit over split damage is h of 2R over h of R. We can graph this. Let's go through this graph. At the far left end, we have the case when AR is minuscule compared to defense. The ratio of damages here is 1. The damages are therefore equal. This makes sense given our previous observations. We know that h is constant for relatively small and large ratios. So when both h of 2r and h of r are within those ranges, they both assume the values 0.1 or 0.9, and the ratio is 1. In between, this ratio is always greater than 1. Here on the right, we see it tends towards 1 again, and in between, it's always larger. This means that the damage of unsplit weapons is greater than that of split weapons. In this particular case, it assumes its maximum when defense is roughly half as large as each split AR, taking a value of about 2.5. In context, if the split attack weapon had 150 physical and elemental AR each, fighting against the opponent with 300 defense each, then a weapon with 300 pure physical AR would deal 2.5 times more damage than a split damage 1. This will take a moment to sink in, so let's look at Chaos Gargoyle Halberd Backstab. That weapon somewhat closely fits our earlier example, with about 300 AR in both physical and fire. We're going to ignore again that usually physical and fire defense are pretty different, and just say a setup has 300 defense in both. We compare to a Crystal Gargoyle Halberd at 900 strength and dex with 600 pure physical AR. On a one-handed light attack, the ratio is Chaos Gargoyle Halberd's 300 AR over 300 defense. So on the graph, that indicates that the crystal weapon should deal about 1.6 times more damage than the Chaos Gargoyle Halberd. We look at 1 and get 1.68, closer to 1.7. Now, the backstabs of these weapons have a motion value of 200, raising the Chaos weapons AR to 600 each, the crystal weapons to 1200, and changing the ratio to 600 over 300, or 2. The graph tells us that now the crystal weapon only deals 1.2 times as much damage. When we look at the ratio of 2, at 1.9 or 1.19, this is at maximum stats. What we can learn is at higher AR with higher motion values, an attack with split AR comes closer and closer to what its AR value actually indicates. On some level, this video was a response to the common explanation that split damage is worse because it, quote-unquote, has to go through 2 defense. As we can see, even when the defenses are equal at extraordinarily high levels of AR relative to defense, using split is no different from using the sum. Indeed, this whole explanation relied on the fact that the damage function is convex. Was it concave, split damage would be stronger than pure damage. Had FromSoft made h a constant instead of a varying function, then the two would be equal. That's all. I hope somebody learned something.